So it's very exciting to have you here. We have an extremely ambitious objective today. So we are trying to find the magic formula. We are trying to find which are the drivers of the innovation. To innovate in healthcare has three main angles, or this is what we think. We need to have great science, and this science needs to be forward to answer relevant clinical questions. And for this, we need investment. So money, science, and patience are the key elements. We all know how difficult it is to create a business, a profitable business, from some ideas to something who is really working. So I really think that I don't want to overwhelm our speakers and our audience, but we are looking for this formula, and we expect that after this session we will be full of energy, thinking that innovation is a way to go for this business, but it's not a way, it's the way with capital letters. So let's introduce Esteve Almirall, who is going to our first speaker. Esteve has an incredible CV. I'm not going to go through, but he's actually professor at the Esade Business School, and he's also the director of the Center for Innovation in Cities, and he will present an opening keynote entitled Business Development in Healthcare Innovation. So I would like to remind to the audience who is online that they may leave all the questions that we will later on going with Esteve. Thank you very much. Looking forward to hear you.
Thank you very much, everybody, and thank you very much to Barcelona Supercomputer Center, to Sara, Disponia, Salvador, all the people who invited me. I don't know anything about healthcare. Let me put that. So I'm going to talk about the things I know a little bit, innovation, AI, and so on. So I'm going to talk about, about innovation. These days we are having, These days we are having more and more innovations like this, innovations that are more on the technical side than before, that we had innovations more in the market side. Let's try to find why this is happening. Let's try to find a little bit what else besides talent, money, and patience do we need in order to create these new innovations that are going to change the world. So my presentation is very simple. I want to answer only three questions. Why do we need innovation? What is innovation after all? And how do we produce innovation? Probably you are more interested in the how. But let's go first with the why and so on. More than 10 years ago, this guy, Mark Anderson, from Anderson Horowitz, said, and that was in 2011, said, software is eating the world. At that time, 2011 was, this guy is crazy. Well, not so crazy. If you look in 2005, the top companies in the world, there were traditional companies, General Electric, Exxon, Microsoft was the only one who was in the tech sector. Now, if you look at 2020, everybody is from the tech sector. Everybody is a software company, but one. Of course, if you have all the oil of Saudi Arabia, then probably you don't need the tech sector. But for that, you need to have all the oil of Saudi Arabia and be Saudi Aramco. The rest, everybody is from the tech sector. Only 15 years in between. How much the world has changed. Maybe we see the change day by day, and we don't notice the tremendous amount of change that we have, but this is what happened. I'm a boomer, like some of you, not many of you. When I was a kid, we were dreaming about these kind of things. This was in our imagination, the Jetsons, flying cars, and so on. Well, Peter Thiel said, well, we wanted flying cars, but we got 140 characters. We got Twitter. So there is a contest here. This is not that fair. I mean, we have all the things. We have self-driving cars that drive pretty well. This is from parking to parking in LA, Tesla, the last version that is almost ready for self-driving cars. And you see it's pretty interesting. You get in the car and, well, it does pretty well in any traffic condition, even in traffic conditions that are kind of complicated. See? It managed pretty well in normal traffic conditions. Well, this is what I'm trying to go. First, why do we need innovation? Then we're going to see what is innovation and finally how. So let's go for the why. And why do we need innovation? Some people, maybe you think that the world has been innovating during the whole history. This is not true. For more than 1,000 years, and before we don't have records, the GDP of the world was flat. From the records that we have is around this in the 12th century, in the 10th century more or less, 10, 11, 12th century. This is the beginning of our records that we have. Since the Roman Empire until 1820, to put a date, it was flat. The growth of GDP was, if you want to know the number that we managed, was 0.05. So basically, nothing. It was no growth. So it was innovation. No, it was not innovation. Innovation is not something that humanity had forever. Innovation is something pretty new. We start an innovation, we say, well, the beginning of the whole thing starts because these are the records that we have. Basically, we don't know. This is the real answer. But the records that we have kind of started in 1820. In 1820, don't think that innovation was great and so on. The growth in 1820 was 0.7. So not that much. But come on, compared to 0.05, it was a tremendous amount and was compound and so on. And after that, well, you know it. This doesn't happen in other countries. Other countries have different rates. But if you look at it, and if you are from the health sector, and probably you know pretty well mortality rates, life expectancy, and so on, looks familiar, isn't it? Looks like things are converging at different speeds, but come on, things tend to be and kind of the same thing. USA was first, now China and India is growing fast, and so on. So same thing is happening here. China is still half of the GDP per capita of Europe, 1/4 of the GDP of the US, and so on. But things are growing fast, and convergence is coming. And we know that convergence is coming. Nothing can be avoided. Convergence is coming, like in life expectancy, like in many other aspects of life. So what is innovation? Innovation is this way that people compete. You know Central America, you know Mexico. In Mexico, one of the typical things from Mexico is, you know, there are maquilladoras. And the maquilladoras, people do products like this. And you may ask, how do they compete? They compete with the cost of the factors. Why they do these products? Because labor is cheap. That's why they do these products. What do you need for competing with the cost of the factors? Well, you don't need many things. You need basic health and education, a little bit of macroeconomic stability, not much, and yeah, some infrastructures to move the products, and that's it. The question is, does it last forever or not? Can we compete like this forever? Just think about it. Well, if you are successful, what is going to happen? Well, salaries are going to raise. If salaries are going to raise, you cannot compete anymore with the cost of the factors. And this is what happened in Spain. This is what happened in all the countries in Europe. So the only way to compete forever this way is to be a failure. If you are a failure forever, then you will compete forever this way. But nobody is a failure forever. Eventually, people succeed. So this way of competing is not working. So after this way of competing comes. I mean, factories come. This was the history of the Industrial Revolution in Europe and so on. And what happened with this kind of way of competing? Well, you compete with the price, with product, with efficiency, and so on. This is the way you compete. You need more things. This is the era of the engineers. You need also financial market sophistication because you need to build factories. You need many more things than in the other case. You need also stability. You need to move markets. You need... Again, we can ask ourselves the same question. can it last forever? Well, as we know, moving one factory from one place to the other is not that complicated. And all these efficiency enhancers that you have competing with efficiency is pretty available everywhere in the world. I mean, good engineers exist everywhere nowadays. It's not like 100 years ago. Institutions and sophisticated good markets to create logistic chains and so on exist everywhere. So probably it's going to be difficult to compete forever this way. So how else can we compete? Well, you cannot compete doing the same things better because everybody can do the same things pretty well. You have to do different things. And these are the industries, and these are the industries where you are. Industries like, I put the ones of the software, there are other ones in healthcare, of course. And think about Apple and so on, the Barcelona Supercomputer Center, of course. Not everything is private organizations. Public organizations are still are there too. And you may think, how do they compete? They compete differently. They don't compete with the cost of the factors. They don't compete with being more efficient. They compete with innovation. And you need different things in order to compete with innovation than the ones that you need to compete with the cost of the factors, than the ones that you need to compete with efficiency, this ratio, price, quality, and so on, doing the same things better, because you have to do new things. And this is where we are. And is this sustainable in the long run? Well, you know it. I mean, all of you compete on innovation. Competing on innovation, doing new things, is way more complicated than copying the same thing that somebody else did, more or less at the same price and at the same quality. It's different kinds of qualities. This is why we may ask ourselves, what is better? We have seen that competing with price, with the cost of the factors, doesn't last, and doesn't last fast. We can see that competing with efficiency doesn't last either. So if we last compete with innovation, probably. Why? Because you create temporary monopolies. If you have a new product that nobody has, you are the only one that you have. And what happens when you are in an economy and you have a temporary monopoly? You set the price, because nobody has this product. And this is the key aspect. In history, our industries are looking for these temporary monopolies. They may last a few years, a few decades, or a few centuries. Depends. Sometimes some of them are very successful. But they at the end, and they all die, these temporary monopolies. But in the time that they exist, come on, they change industries and they change countries completely, because you set price. You don't accept price. You set the price. That's the different thing. And this is what competing with innovation brings on the table, this capacity of doing temporary monopolies. That's why everybody's interested in innovation. That's why everybody wants to innovate. Not because it's cool, but because you can create temporary monopolies that set price. That's why. So let's talk about innovation. What is innovation? And of course, innovation talks about novelty. Innovation talks about all type of qualities, adoption, and about changing things, and so on. These are the three characteristics of innovation. But we have kind of two types of innovation. And we will see that these two types are a continuum. The first type is when you have an invention risk. And this is where you are, most of you. When you have to invent something that nobody knew how to do. We don't know how to do it. And then somebody discovers a way to do it. And this is the invention risk. And this is where you are. And this is a specific type of innovation. There is another type of innovation, very more common probably, that we have a market risk. I mean, there is not a mystery on how to do things, but the mystery is going to be accepted by the market or not. Let's have some examples. And, well, this portrait shows probably the two types of people that represent this invention risk and this market risk. Two types of people interested. And this is a continuum. And let's see how things are in this continuum. A typical market risk is, for example, an electric toothbrush. We have electric toothbrush since 1930s. They were with a cord and were connected to the, and so on, and then they come and go and so on. Is that a big problem to make an electric toothbrush? No. I mean, people are going to buy it or not. That's the problem. Not in making it. In making it is pretty simple. Let's have more things. Let's think of boiling water. Well, we know how to boil water. So the Nespresso could have been invented 50 years ago, of course. There is nothing in the Nespresso that we didn't know how to do 50 years ago, even 100 years ago. The problem is not the technology here, because there is no technology. I mean, yeah, there is some engineering challenges and so on, but pretty minimal. I mean, the problem is the market is going to accept it. And we have the same thing with brands. I mean, making a coffee shop, come on, we have coffee shops since the 17th century. I mean, that's nothing new. Since coffee came, we have coffee shops. So can Starbucks be in, I don't know, in the Victorian age? Of course, it can. And the other thing, we have invention risk. Imagine that you discover the cure to cancer. Do you need marketing? No. People are going to tear down your house. You don't need marketing. You don't need anything. You need the discovery. That's all you need. It's a different world. It's a completely different world. Imagine that you cheat that, or imagine that you can prolong that 10%. Same thing. Do you need marketing? No. No problem. You don't need any of these things. It's not a market test. It's just nobody knows how to do that. If somebody discovers, many things are in between. Are in between this invention risk and this market risk. And these are more the things that we know. And for example, Akiba, this is the robot that manages the Amazon warehouses. It's in between of these things. Making Akiba, it's complicated, you have to do things, but come on, it's not tremendously complicated. It navigates through QR codes. We know very well how to do QR codes. There is not such a huge technology behind. But you have to feed that into the warehouse. You have to, it's kind of in between. We will see. And sometimes you have inventions, like many of you, in medical devices, for example, that are in both places. But you have components that are invention, and you have components that is a market risk. Both are complicated. Why? Because in the market risk, you need to create social meanings. You need to change the way that the society works. And when you say, I call somebody, 50 years ago was taking a phone and calling. Now it's sending a WhatsApp or God knows what, a text message. Of the meaning of call changed completely. The same way the meaning of taking a photo. Taking a photo was having a camera and so on. Now it's just you have your smartphone and you take a photo and your video. This social aspect takes time. There is no way to accelerate social adoption and the creation of social meanings. There is no way. This also takes time. So many times you are in both. Well, let's talk a little bit more about this model. The way that you deal with one thing and the other, it's completely different. When you want to solve market risk, well, you think about things like design thinking, focus groups in the old time, and so on. When you are in between, you have these engineering methodologies that are kind of in between. Kanban is probably the most popular. Experimentation, it's probably the most popular here. And when you are in the invention risk, we are still stuck with the engineering methodology, making a project, making a hypothesis, trying to test this hypothesis, and so on. Well, the truth is that this doesn't work so well. It's difficult to know what the society will accept or not. That's very difficult, it takes time. And these don't work so well either. And this works pretty well. So, but works pretty well, but gets stuck into tunneling in a very narrow vision. It doesn't broaden the whole thing. So we have a methodological problem here that probably many of you know this methodological problem. Also, let's talk for a second about risk. And here maybe you will understand, or you will see why we have so many innovations here. There is quite a big risk when you have a market problem, because you don't know what the community will adopt. It's something that it's difficult. You have to test it, you have to create social meanings, you have to create adoption. It takes time. Maybe things succeed, maybe things don't. You don't know. I don't have to tell you how much risk you have in invention. I mean, we wish that our hypotheses were true all the time. That doesn't happen. So we have a lot of risk in invention. Here, you share both things. You don't have to invent new technologies, you have to apply new technologies. That's a big difference. Probably we know much better how to apply new technologies. And when you have the kind of market risk that you have here, is the kind of, well, if this product lasts 10% more, it will be accepted or not? Of course it will. Because it's obvious, the question. You separate a multi-factor problem into a very small factors, not all the factors. And that's why companies think here, we call this incremental innovation. But it has a little bit of both, and this is what happens. Let's talk also about the time it takes to get one innovation done. The time it takes to get this minimum viable product, this prototype, this early prototype to test things and so on here, it's nothing. I mean, normally it's a web. Not even that. It's kind of nothing. The time it takes to make an early prototype here, well, it was growing and growing, and when you go to this area, and we have to invent things, and you need an early prototype, it takes time. Because you have to solve many, many, many problems. So these are two different worlds. I guess you are more interested in this world. So let's talk a bit more about this world, and how this world happens. And this is the how. How you innovate in this world, in the world of the invention. In the other world, there are other ways, but probably it's not so much your interest. And I will take some examples of AI, because it's what I know. I don't know anything about healthcare. So how can I put examples of healthcare? But on AI, I know a few things. And let's take, for example, the Netflix prize. The Netflix prize is probably in recommender systems. Besides movie lens, was a big thing. The Netflix prize was Netflix put a prize, a competition that lasts from 2006 until 2009 that says, I will give $1 million. At that time was quite a lot of money. To the team that beats my recommender by 10%. So improves my recommender 10% only 10% better. It's not that much. Well, lots of people. Well, there were some conditions in this Netflix prize. One of the conditions was you have to disclose the code when you submit it, or you have to disclose the algorithm when you submit it, and so on. And this was the rate of improvement. Probably you will see some familiarities with what you do. In the beginning, it's easy to improve a lot. At the end, it's very complicated to improve only a few percentages. This characteristic of very incremental innovation building on the shoulders of the ones that were before you, this is so typical of invention risk. This is one of the main characteristics of invention risk. And if you see the different teams and how the different teams submit solutions, you will see also this sparsity. This sparsity in the beginning, and then the concentration at the end. At the end, everybody was doing the same, because the code was disclosed. Even if the code was not disclosed, well, you will know what were the algorithms and so on. And because there is labor mobility, there are podcasts nowadays, there are everything that people disclose the technology, and because with this insight, you can imagine what they are doing. There is not rocket science that is secret somewhere anymore. So you will see a big concentration of people here and a lot of sparsity there. And this is a typical thing. Let's have a second example. And the second example I have is convolutional networks. Convolutional networks has been probably, in deep learning, the most successful thing that we had. Everything started with this paper from Geoff Hinton and Alex. Convolutional networks is, in deep learning, these algorithms that can recognize image. This is, again, pretty interesting. Well, this is the design of a convolutional network and so on. This was very successful because, well, before that, we used things like similarity measures, k-means, things like that. And then when convolutional networks appear, they were better 17%. Just in the beginning, it was a huge jump. And this put the whole convolutional network on this spot. Because, come on, that never happens. This is something that doesn't happen in AI. Nobody makes an algorithm 17% better than the one before. These were the two types of image. You have a training set and you have a test set and so on to train your model and so on. As you can see, the images are not so clear and not so easy to see what is in the image in some of them. In some of them it is, but in some of them it's not. And then what is the benchmark? The benchmark is you have to guess the first one, the top one, or the top 5, or the one that you guess is in the top 5. These are the two benchmarks. Well, what is the success? This is the success. We were at 30% accuracy, and then with AlexNet, we just went 17% better. And in 2014, more or less, we can do it better than any human on planet Earth. So from mid of 14, that we do better than any human on planet Earth, we keep improving, and now machines have to compete with machines because, well, they cannot compete with humans anymore because they are too bad. They are not. And this is the rate of improvement, and this is also the rate of, as you can see, there is a concentration on the top and so on. And you wanted a receipt. Well, this is the receipt. So it's more than talent. What is happening here? Well, here we have a data set. Maybe you like it or not. In this case, this is a data set. Maybe you like it or not. In the case of Netflix, was Netflix data set, there was 1 million ratings. But we need a data set. We need something. With this data set, we need an agreed benchmark. In convolutional networks was top 1, accuracy top 1, top 5, and so on. This was, and in the case of Netflix price was RMSE, that was the agreed benchmark that we were using, and so on. We need transparency. Either clear transparency or forced transparency, like in the case of the Netflix case, where you were forced to. We need incentive management. Come on, $1 million. Yeah, that's incentive management in the case of Netflix case, or well, you publish in the NeuroIPS and so on. That is the most famous conference in deep learning in image and so on, particularly in image, but in general, in deep learning, you get a good job immediately. So it's very difficult to publish that. What do you have? Well, you have competition. Competition is basic. You need competition. But you also build a community of researchers around this data set, around this agreed benchmark, around this, and you evolve. And you have seen the evolution, and this is what produced this evolution. Well, what is the problem of that? Well, the problem is that this is commons. And the commons, you have this tragedy of commons. No? I mean, if everybody, instead of going to the traffic jam, has been in the other road, it would be better and so on. There is no incentive in building the data set. There is no incentive in doing all this stuff. There is no incentive. It's commons territory. So either you have a company like Netflix, or you have something that happens like in convolutional neural networks, or you have the public sector, or you are not going to have this, and you're going to have to suffer the tragedy of commons. And then it will be more difficult to advance. So this is the recipe. We have been talking about 3 basic things, about why, about what, and about how. Thank you so much.